Okay, children. So like that. So this here some terms I have to explain. Pi is nothing but initial phase, children. Initial phase. You can also call it as initial epoch of the particle also. Initial epoch of the particle also you can call. And I told you many times, A is amplitude and omega is nothing but angular frequency. X is the horizontal position of that particle. Always we will analyze that particle only, children. Pi is nothing but initial phase. I mean, which will describe the initial status of that wave or particle. Understood? For example, I will tell you. Initially, for example, initially means when time equal to 0, I mean the particle which is at origin and its displacement is equal to something plus a by 2, children. So what is the initial phase? How to write the equation? So put all the initial conditions in the wave equation, children. So how we can write? Y equal to how much, children? A by 2, A equal to sine of pi. Okay, A cancels out. So sine pi is equal to how much, children? Sine 30, I mean pi by 6. Sine cancels out. So pi is equal to pi by 6, children. So substitute here. So you will get the y is equal to how much, children? A into sine omega t minus kx plus pi by 6. Understood? This is called wave equation. This is called wave equation that is moving in positive x direction. That is moving in which direction, children? Positive x direction. Then how we can write wave equation that is moving in negative x direction, children? Respond. Wave equation that is moving in negative x direction. How will you write? Tell me, children. Very simple. Y is equal to A into sine omega t plus kx plus pi, children. That's it. So it is very simple. So you can interchange also. In some books, it will be written any wave that is moving in the positive x direction. They will write y is equal to A into sine of kx minus omega t plus pi will be written. Nothing will happen, children. This is also correct. This is also correct, children. But if you take this into consideration throughout the analysis, you have to take this equation only. And if you want to take this one, omega t minus kx plus pi, so throughout this analysis, you can take this also. But you should continue, you should stick to any one concept. If you take this now, pi value will come differently. And if you take this no, pi value will come different in some cases only. Now, if any wave going in the negative x direction, so what we can write? The wave equation y is equal to a into how much, children? Omega t plus kx plus pi you can write. And y is equal to how much, children? A into sine kx plus omega t plus pi also. Nothing wrong in this, children. All are same only. Is my point clear? Say yes or no? So copy very quickly, everybody. Shall I move the slide, children? Shall I move the slide?
Yes, sir.
So, okay, children. So I think everyone understood very clearly and very nicely how to write the equation. So it is a very important skill and a very key skill. If you have that skill now, so you can do anything in this wave equation, children. So some more uh, properties. Let us continue. So I will take one same thing, children. One wave I am taking. Wave means what? Transverse wave only I am taking for better understanding. Means one particle is there at a distance x meter, and it is doing throughout its lifetime. The particle is doing the vertical oscillations. I mean along y-axis only. So at the time t seconds, the particle vertical displacement is y, and nicely one wave also traveling in the positive x direction, children. So kindly respond. What is the wave equation? Tell me, children. Respond. How will you write the wave equation? Y is equal to a into sine of omega t minus kx plus pi. Kx minus omega t also you can write, children. No problem. Only pi value will change. Nothing will happen. That's what if you are referring any 2-3 books now, so don't confuse. Both are same only. Omega t minus kx you can write. Kx minus omega t also you can write. Is that point clear, children? Now we have some. We'll address some few more properties. Velocity of the particle, children, after t seconds. Velocity of particle after how many seconds? T seconds. What I should do? Tell me. Velocity of the particle is nothing but change in vertical position of the particle divided by time taken. We substitute y value how much? A into sine of omega t minus kx plus pi. K, don't touch it. What the differentiation of sine, children? Cosine will come. Omega t minus kx plus pi will come. Again, these terms inside the bracket also you have to differentiate. So generally it is a partial differentiation I have to do, children. What the meaning of partial differentiation? Except time, everything constant. So x constant, k constant, pi constant, omega constant. Understood? Means only omega will come outside. Understood? This is the velocity of the particle after t seconds. Everyone must and should remember at your fingertips. What is acceleration of the particle after t seconds, children? Acceleration of particle after t seconds. Acceleration of the particle after t seconds. What is acceleration of
Pi
the particle?
sine
Change in,
omega plus kx.
very good, very good. Change in velocity by change in time taken. To differentiate, if you put this value here, what will you get? Minus a omega square into sine omega t minus kx plus pi. These are three equations, children. Everyone must and should remember. Now, once again, I will revise briefly velocity of the wave or speed of the wave. Velocity of the wave or speed of the wave, that is denoted with the symbol Vw. This is Vp. Vp means velocity of the particle. Vp is different, children, and Vw is different. So the velocity of the wave, someone, if they define, I will listen. What is the velocity of the wave, children? Tell me. Respond. Velocity of the wave is nothing but the displacement of the wave in 1 second, that is nothing but wavelength, and time taken by the wave in complete production of one oscillation, nothing but time period. This is one particular format, children. Many formats are there. We'll write few more formats. You can also write reciprocal of time period. What we can write, children? Frequency into wavelength also you can write. The velocity of the wave. F is also can be written as omega by 2 pi also I can write. Into lambda also I can write. And also 2 pi by lambda is nothing but wave number. So here we have got one more parameter is called wave number, children. What is the meaning of wave number? The number of waves can be accommodated in 1 meter is called wave number. Number of waves. Number of waves can be accommodated in 1 meter is nothing but wave number, children. So that is number of waves accommodated divided by what is that, in 1 meter is the total distance. How many waves you can accommodate? You can write n into 2 pi and divide by total distance traveled is nothing but n into lambda. N waves travels a distance n lambda. N cancels out, so k equal to how much? 2 pi by lambda. This is a formula for what here, children? Wave number. Is that clear, children? All formats everyone must and should remember. More repetitions required, or else you do not remember. Now here we have few more parameters I want to introduce, children. Phase of a wave. Phase of a wave, children. Just now I told phase. What the phase means? Just now I wrote wave equation. That is A into sine omega t minus kx plus pi. Phase means angle. This total angle associated with the sine term is called phase, children. What is the phase of the full wave? Omega t minus kx plus pi. Everyone must and should remember at your fingertips. Different formats also I can write. Omega I can write angular displacement by time taken. And k also I can write 2 pi by lambda into x plus pi also I can write. So the phase is nothing but 2 pi if you take it outside, t by capital T minus x by lambda plus pi, children. And now if you see the phase difference of the wave, phase difference of the two waves, children. So the phase of the first wave I can write, children, 2 pi by t by capital T minus x1 by lambda and plus pi, children. Both are in the same phase. In the another same initial epoch I am taking. Another phase is, phase of the second wave is I can write t by capital T minus x2 by lambda, and that is also in the same epoch, initial epoch I will take. You see the phase difference means what, children? Phase difference meaning final phase minus initial phase is nothing but phase difference. Delta data is nothing but final phase theta 2 minus theta 1. If you put all the values, you will get one more important relation. That the phase difference delta theta equal to, you will get 2 pi by lambda into the path difference. X2 minus x1. Is the relation between, is a very important relation, children, in the waves discussion completely. This is relation between phase difference and relation between phase difference and path difference. I told you two waves are, this is wave number one, this is wave number two. They are, for example, you just copy first, copy quickly. Children, shall I move the slide on? Yes, sir. Okay, children. So now, if you look into the few more parameters, children. So, for example, See one example, children. This is one wave. This is another wave. This is one point P. This is the distance traveled by the wave is delta 1, and time taken by this first wave to reach the point P is t1 seconds, and the phase of the wave is phi 1. If you take this second wave, children, the distance traveled to reach the point P is delta 2, children, and the time taken is t2, and the phase of this wave is phi 2, children. I mean, what I mean to say, between the two waves, children, there is some path difference is there, and phase difference is there, and time difference also there. I mean, the one wave is produced means one full circular path completed. I mean, the angle swept by the radial line is 2 pi, and time taken to complete one revolution is capital T, and the distance traveled by one wave is nothing but lambda. I mean, I can write one statement. If two waves produces, so it will revolve 2 rounds, children. Means the phase difference become 4 pi, time taken is 2t, and distance traveled is 2 lambda. I mean, what I mean to say here, we have got one relation. The phase difference is proportional to time difference between the two waves, and directly proportional to path difference between the two waves. To give a perfect equation format, children, I can keep some constant. So I can write phase difference between the two waves divided by 2 pi equal to time difference between the two waves divided by capital T equal to path difference between the two waves is nothing but lambda. So this is a very, very powerful equation, children, to understand the wave or wave nature of oscillation. This is a very key equation, key relation, children, and very important also. So everyone must and should remember at your fingertips. So you will understand in the future how I am going to use it also. Without that, we cannot do anything. So now coming to the point straightly, we have got some relation. I mean, relation between velocity of particle and velocity of the wave, children. Just I will write the two equation. Already we have deduced it. One more time I will write. The velocity of particle is nothing but we got a into omega into cosine omega t minus kx plus pi, children. And velocity of wave also I told one equation. What is that? Omega by k I can write. Omega by k. Keep aside equation number 1 and equation number 2. We know the displacement of the particle any time t second. I mean, wave equation equal to a into sine omega t minus kx plus pi. I will differentiate on either side with respect to x. In the dou y by dou x equal to a I won't touch. What differentiation of sine? Cosine omega t minus kx plus pi. But one more time I have to differentiate, children. That is omega t minus x plus pi. I told you now the partial differentiation meaning except x everything is constant, children. So I can also write dou y by dou x equal to a into means only minus k will come outside. So minus k into cosine omega t minus and kx plus pi, children. This is the equation number 3. Now what I will do, I will divide the equation number 1 with equation number 3, children. So if you do like that, you'll get Vp by dou y by dou x is equal to a omega into cosine omega t minus kx plus pi and the whole divided by minus a into k into cosine omega t minus kx plus 5. A cancels, children. So velocity of the particle is nothing but what I can write, tell me. This also cancels out. So minus omega by k into dou y by dou x. This is another powerful relation, children. I don't need to explain what is the omega by k is nothing but velocity of the wave, children. Yes or no? You can write velocity of the particle equal to minus velocity of the wave into dou y by dou x. Very, very powerful relation, children. Some tricky questions are there to address. This is work like anything. Now, one question I will ask. By applying this equation, everyone have to answer, children. Are you ready? Huh? See, one wave is going like this, children. The positive x direction it is going. There is one particle p is there, children. My straight question, at this instant, at this instant, at this instant, particle moving in which direction? Upside or downside? Everyone have to tell, children. I'm again repeating, children. This is one wave produced in the string. The wave produced in the string moving in the positive x direction. I have shown one particle. The particle moving in which direction? Up or down? That's all. I want this answer. The clue is here.
Sir, up, sir.
Who is this up?
Up
direction, sir.
Who is this?
Jones, sir.
Aura Jones. Tell me, Jones, what is your explanation? How? Justify.
Sir, if the wave moves right side means the particle of the medium vibrates in perpendicular direction. So I told upside direction, sir.
Repeat. I didn't understand. Once again.
Sir, as it is a transverse wave, the wave moves right side direction. The particle of the medium vibrates in perpendicular direction, sir. So I said upward direction.
Okay.
Sir, upward directions.
Who is this?
Dinesh, sir.
Dinesha.
Yes, sir.
Okay. Okay, a very good explanation and correct also. Very simple. What you need to do, you have to apply this concept. At point P, you need to draw just one tangential line. Tangential line representing what, children, tell me? Slope only, no? What is slope of the tangential line? dy by dx. This is positive or negative, or children? Slope at that point P? Negative only, no? So I will give some number minus 10. So velocity of the wave, I will give one number plus 10, children. Understood, children? So substitute here. Sorry, here you substitute. What the velocity of the particle, tell me? Plus 10 and dy by dx is minus 10. So how much velocity of the particle is? Plus 100 means the particle is going up only. Is my point clear, children? Say yes or no. Positive means positive y-axis only. Understood or not understood? Respond, children.
Yes, sir.
Okay, one more question. One particle is going left side, wave is going left side. There is one another particle P is there. So same question. At this instant, particle moving in which direction? Answer everyone. Is there
Upward.
again upward? Huh? Who is that?
Yes. Upward.
Asparka. Hello. Good evening. Okay, madam. Did you WhatsApp your resume, madam? Not 2 months. Not 2 months. Recent only. 1 week only. It is open. Madurai, no vacancy. Some other places are there. It's a national brand. No, you just WhatsApp your resume if you are interested wherever you want to relocate. So, okay, madam. Just immediately WhatsApp your resume. I'll send one link. Just fill that details. Okay, HR people will contact you. Okay, right time. Okay, who gave the answer? Ra?
Sir,
Sir,
downward.
downward, sir.
Who is downward, guys?
Dinesh.
Jones.
Jones, sir. Dinesh also. Okay, it is my turn, Ra. I'll assume the velocity of the wave -10 and I will draw one tangential line to the point P. So the slope dou y by dou x, how much children tell me? -10. So substitute this that Vp equal to minus velocity of the wave into dou y by dou x children. Put everything -10 into -10. So this -100 like that it will come. Minus means what children? Down only. Understood? Everybody?
Yes, sir.
Understood, my dear children? Okay, copy quickly. Tomorrow, morning 8 to 10 o'clock I will take. Okay. Understood, children? Same waves I will take tomorrow. Clear on. Everyone should attend. Are you understanding
Sir,
what I
can
am
you
saying?
take the class from
Huh?
5 to 8, sir?
What, Ra?
Morning 5 a.m. to 8 p.m. 8, sir.
Who is that?
Jones, sir.
5 morning 5 a.m. Okay, we'll done 5. But everyone okay, na? Some are telling morning you will wake up, I will wake up. But many don't come, na? Efforts will waste. I will take night 3 o'clock also, but they should come, na? Eight to 10, okay, na? What Jones?
Okay,
What is
sir.
the problem, right? 8 to 10.
Sir, I can come.
Uh, 5 a.m. Many are not coming. This is basics, na? Understood. 8 a.m. to 10 a.m. I will take. Okay. Okay, children. So that's all today. Shall I close this?
Sir,
I'll
can
share.
you show last page 1 minute?
Sure, sure. Tomorrow class only online, children, morning 8 to 10 online, and the remaining 11:20 to 5 as usually offline only. Okay, clear? Only online mode, morning 8 to 10. Clear, children? I will post the message now. Okay, children, thank you. We'll meet tomorrow at 8 a.m. online only. I shared the link and details, everything. Thank you. Bye.